Okay, so basically, today we are going to start the concept of determinants. Here, when I'm discussing any topic, and if you feel like if you are having any question which is related to the same topic or maybe any other topic, you can ask the question. So I believe you are practicing with me. First, we have done the revision of the first chapter, the second chapter, and third chapter. So you are also doing the same. Like here, we are discussing. We all are discussing it together, and then at home you are practicing the exercise. You are doing different types of question from the question bank also. So I believe that effort you are applying from your side, then and only then there will be like this revision series which we are continuing, that will be successful. Okay, so please do the same, or just practice the question from the same chapter by yourself also. Then you will be able to find where exactly you are facing problem, if any question is there which is not clear to you, and you will be able to resolve that. Okay, continue. So we are going to start today the next concept. The next topic after matrices is determinants. So basically, determinants is just like a number, a value. Whenever we'll be finding the determinants, when the all the numbers are given, all the values are given, then we'll end up, when we will find the determinant, we will get a value which will be associate. This determinant is a value which is associated with the square matrix. Okay, so square matrix, we have already done the discussion what exactly is a square matrix in the form of 2 cross 2, 3 cross 3, where the number of row and the number of column is same. That's called a square matrix. So here, this determinant is associated with the square matrix. We will be having determinants like this, maybe 2 3 4 6, like this. And you must know how to find the determinant of this one. We do the multiplication, like 6, 6 we multiply with 2, 2 into 6 minus 4 into 3. Okay, this that will be 12 minus 12, and here it will be 0. Okay, similarly, if we are having 1 4, uh, let's say we are having 3 9. So if we will find the determinant of that, it will be 9 minus 12, that is 9 10 11 12 minus 3. Okay, so this is how we find the determinants. Now when we are having, basically the formula or the process of finding the determinants is, quickly I am telling. If we are having a square like form, which is a b c e f D, E, F, G, H, I. If we are having this type of determinants, then here the symbols are like, this is positive, this is negative, this is positive. Then negative, positive, negative. Then positive, negative, and then positive. So this is how the continuation of the symbol goes on. And how we do the expansion. So we take the first element A, and then we cover it. We cover this one, we cover this one. And then as you can see, the remaining is, let me remove it first. Whatever element we have taken, that row and that column, we have to cover it. Okay, so the remaining over here will be E, F, H, I. Then we'll be taking minus B. Okay, because B is negative over there. And then the remaining, please don't take the other numbers with the sign. Okay, this sign we will be taking only when we are with the this outside number or this outside value. Okay, here A is positive, I have written A positive, and the remaining one as it is I have to write, no sign is there. Sign is only, why I have written the sign, I want to explain, just discuss here that you can expand it by taking the first row a b c, the first element at first, or you can also expand it by taking this d e f also. The process will be same. Whatever element you are choosing, just cover that row and that column and write the remaining elements. Okay, so I'm coming to that point also. Here minus b we will be having, I'll be covering this column and this row. And as you can see, we are left with d, f, g, I. Now we'll be taking plus c and we will cover that row and that column. So we will be left with, uh, if we will cover it, yeah, if we will cover this row, this column and this row also, then we will be left with D, E, G, H. D, E, G, H. Okay. This is how we will be expanding the given determinants, and then we will be able to get the value also. So here A, and then in bracket, first we do multiplication like this, and then we do multiplication like this. So it will be EI minus FH. Minus B, it will be DI minus FG. Then plus C, it will be DH minus EG. Is it okay? This is how we do the expansion. Okay. This must be clear to you, and if it is not clear, uh, this is how we do the expansion. We will be doing the expansion in the question also. So this is the process of expanding it. I was saying that even if you will take, even you suppose I am taking the second row and I want to expand by taking the second row. Okay, so instead of the first method, I can write as a minus d. Okay, now the same process. Since I have taken D, I will be covering this column and this row. What we are left with? We are left with B, C, H, I. Okay. Now the next element will be taking, yeah, the next element we will be taking from here only as a positive E. Okay, like this. And then we will cover this column and this row again. So as you can see, we are left with A, C, G, I. Okay. And then we will be taking the third element, F, that is negative F we will be taking, and we will be covering this row and this column. So we will be having A, B, G, H like this. If you are going to expand like the first one which I have shown you, which we use in general, always we take the like first row and we start expanding it. So if you are doing it like that, or if you are doing it by taking any other row, any other column, then the same answer you will be getting. Okay, it will not change the answer. Now let's find one determinant, the very basic question from this chapter. So what's the determinant of, what is the determinant of 0, 2, 0, 2, 3, 4, and here 4, 5, 6. This one, the question over here I have taken from the previous year question paper only. Okay, so this question you can expect in like MCQ question, 1 marks question. Okay, where the answer will be there and you have to take mark. So whenever whenever we are having determinants, we will just see that which row is having maximum number of 0. If we will start with that row, if we will start expanding by taking that row, that will be like that way we will be able to save time. So here we can see the first row itself is having maximum number of 0. So the first, if we will expand it, just let's see uh, here I am writing each and every step, but you don't have to write. Okay, quickly you can expand it, you can find the answer, and you can mark the correct option. So here if we will be expanding it, first number I have taken as a 0, and then it will be 3 4 5 6. Then the other one will be -2, and then it will be, we will be covering the row and column, and we will be having 2 4 4 6. Then we will be having +0, and then 2 3 4 5. Here you can see we don't even have to do the multiplication and expansion of this part and this part, because whatever we will be getting, that will get multiplied with 0, and it will be 0 only. Okay, so this two part we don't even have to do. And when you are going to expand it by yourself, you only have to write this term. You don't even have to write the first and the last term if you are doing MCQ question. Okay, please don't just spend time over here for writing everything and then understanding okay it will be 0. You should know that when we are having the elements as a 0, eventually it will give 0 only. So that's why I am telling that if we will start with the row which is having maximum number of 0, it will be beneficial for us. We will be able to save time. So here only -2 and this one. So -2, now 6 2 times 12 and 4 4 times 16, which will give us -2, 12 minus 16, 4, -4. That is 8 is the answer. Let's move ahead. Now the next one is just a moment, let me take one more question. It says that show that the determinant x minus sine theta cos theta, here sine theta minus x 1 cos theta 1x is independent of theta. So once we will find the determinant, that the value or the our answer should be independent of theta. What is the meaning of independent of theta? Theta must not be there in our answer. That is the meaning of independent of theta. Let's see whether after solving, let's see after solving whether whatever answer we are getting for the given determinant, is it independent of theta or not. So we are having, here only I am expanding it. So we are having x sine theta cos theta. Let's expand it by taking the first row only, which we take always in general. -1 minus x 1 1 x. Here we'll be taking minus sine theta, and it will be minus sine theta cos theta. If you are not getting how I am writing this term, please let me know. I am doing it quickly. Here I am just covering this row, this column and this row. Okay, we have to cover the corresponding column and the corresponding row. Okay, the element which you are taking, you have to cover the column which is related to that element and the row which is related to that element. And after that, whatever we will be getting, that we have to write it over here. So we will be having minus sine theta cos theta. Here we'll be having 1x. Now the next one is cos theta, the last term. And here we will be having minus sine theta cos theta and minus x. Just a moment. Here minus x. Wait. Yeah. Here minus x. And here only 1. Okay, let's expand it here. So we will be having x minus x square plus 1, right? Sorry, it's not plus 1. It's minus 1. Okay, previously also we have written negative, no? Yeah, here minus sine theta, we will do crisscross multiplication like this. So minus x sine theta minus cos theta plus cos theta. Here we will be having minus sine theta, and then minus, here we have minus x and minus plus x cos theta. Okay, if this one you can check over here, we are having nothing but this 4. Okay, minus sine theta cos theta minus x 1. Okay, so it will give us minus sine theta and plus x cos theta like this. Okay, let's simplify it. So we will be having minus x cube minus x minus minus plus, that is plus x sine square theta, then minus plus sine theta cos theta, then minus sine theta cos theta plus x square cos square theta. Here we can see minus plus sine theta cos theta minus sine theta cos theta. It is cancelling each other. Okay, so we are left with minus x cube minus x here, this one and this one. If you will focus over here, you will be able to find. Wait, am I missing anything? X square. How I have written it will be only x. Okay, it will be only x. As you can see, cos theta multiplied with x cos theta, it will be only x cos square theta. Okay, so if you will see here carefully, the both the circle part, you will be able to find that we can apply the identity over here, the trigonometric identity. Okay, so that is x we can take out common, and it will be sine square theta plus cos square theta. That's why we say the whatever concept you are learning in the first chapter, second chapter, third chapter, and basically in the trigonometry, mostly in the trigonometry or inverse trigonometric function, whatever you have learned, that you are going to use everywhere. Okay, in all the chapters, while doing integration also, while doing differentiation also. So here we'll be having minus x cube minus x and then plus sine square theta cos square theta. The identity is 1, so x times 1 or only x we can write. We can see x and x is cancelling out each other, and we are left with minus x cube. What we wanted to find, we wanted to show that the determinant of the given, like the whatever given determinant we were having, that's the result, the value which we will get after solving that, that will be independent of theta. So the answer will not contain theta, and yes, we have shown that our answer is not having any theta, it is independent of theta. Okay, is it clear to everyone? Now if we are having one of the question like this one, that let's say we are having x plus 1 over here, x minus 3 over here. Here we are having x minus 1, and here we are having x plus 2. And on the other side, if we are having 4, 1, negative 1, 3, then we have to find the value of x. Then find the value of x. So the way we used to compare in matrix, that the first element over here is equals to first element over there, the second element over here. What I mean that the way we used to compare in matrix, that this is equals to this, or maybe this one is equals to this one. This concept we are not going to apply for determinants. Okay, we will never ever compare the terms like that. What we can do over here, we can find the determinant by following the process of expansion on the left hand side, and we can find the determinant by following the process of expansion on the right hand side, and then we can compare both sides. Maybe we can compare the coefficient of x square with x square or whatever, like that we can compare. But here the terms, each and every term, we will never ever compare in determinant. Okay, so Let's find the determinant on both sides. So we can say it crisscross we will do. So it will be x plus 1 into x plus 2 minus x minus 1 into x minus 3. That has to be equals with 4 3 times 12 plus 1. Okay, let's continue. Here we'll be having x square plus 2x plus x plus 2. Here we will be having minus. Let me give the bracket at first, because once we will open the bracket, due to this negative sign outside, each and every sign will reverse. Okay, that's why I'm keeping every term in bracket at first. So it will be x square minus 3x minus x square minus 3x minus x plus 3. Okay, that is equals to 13 over there. So here we are having x square, 2x plus x will be 3x plus 2. And here let's simplify at first. So minus x square minus 3x minus x will be minus 4x plus 3. And here we'll be having 13. Okay, here we are having x square plus 3x plus 2. And let's open the bracket now. Okay, so minus x square, here minus, it is plus 4x, and then minus plus minus 3 is equals to 13. We will be having, we can see here, these terms are cancelling out each other. Okay, let's cancel them. Now most of the student, even applying the same method and expanding it like that, they will end up doing mistake with this minus sign. Okay, if you will try opening the bracket over here only, there is a chance that we will end up doing mistake. So to avoid those mistake, one more step, if we are doing, that is perfectly fine, please do it. Okay, then we can avoid such minor mistakes. Now x square cancelled out. Here 3x, here 4x, that is 7x. Here plus 2, here minus 3. Yeah, that is negative 1 is equals to 13, and easily we are able to find the value of x. That is 14 and x is equals to 2. We wanted to find the value of x when the given condition is given, and we have found the value of x. We will not compare the elements when we are solving, when we are having determinants. Okay, let's move ahead. Okay, few properties are there for determinants. Let's see what are those. So the properties, the first property is determinant of A will always be equals to determinant of A transpose. Okay, transpose we also write as a dash. Okay, like this. So determinant of A will be equal with determinant of A transpose. And the next property is, yesterday only we have discussed the concept of transpose, that when we are changing, writing row in the form of column, then we will be getting the transpose. So determinant of A and determinant of A transpose will be same. Now the next property says, if we are having, we represent the determinant with this delta. Okay, this is called delta. Here, by A, B, C, D, E, F, suppose we are having this determinant G, I. So if we will exchange the rows, suppose here row 1, and I am exchanging row 1 with row 2. Like I am writing row 2 in the first row, that is D, E, F, and row 1 I am writing here A, B, C. Okay, and the third row I am writing as it. When we will be doing something like this, then the sign will get reversed. Okay, this if previously it was delta, now I have to write minus delta over here. Okay, so whenever we will be exchanging the row, we have to reverse the sign. This property you will be able to apply when you will be applying the row operation. Then while doing the row operation, sometimes we do the like we write row 1 as a row 2 and row 2 as a row 1. That time we have to write minus sign in front of the determinant. Okay, so this is also the one of the property. Now the next property is, if we are having two row as a like, if this is ABC, this is also ABC, and this is DEF, just like that. If two rows are same, then the answer will be 0. Okay, now the next property says, suppose we are having k, any scalar multiplied with a determinant. Suppose we are having this type of arrangement, then in matrices what we used to do, when we were having k and there is a matrix, let's say matrix A. Suppose there is a matrix A which is 2, 4, 3, 1, 5, 6, 3, 5, 8, something like that. If we are having the matrix, and when we used to multiply k in the matrix, what we used to have, 2k, 4k, 3k, k, 5k, 6k, 3k, 5k, 8k. This is how we used to do the multiplication with the scalar. Okay, yesterday only we have discussed this concept. Now here when we are talking about the determinant, that's why most of the time now student get confused with the matrix concept and the determinants concept. This is because both are in some way, both are similar to each other. That's why confusion arises. So when we are having a scalar multiplication over here, and suppose we are having a determinant, suppose A, we are having as 2, the same 2, 4, 3, 1, 5, 6, 3, 5, 8 in the determinant form. Okay, if we have to multiply k like this, then it will only get multiplied with any one of the row, or maybe any one of the column, not with each and every element. So we can only multiply it like 2k, 4k, 3k, 1, 5, 6, 3, 5, 8. This is the meaning of k into the determinant. We will not multiply with each and every like element from all the row, all the column. Okay. So that's the difference between the matrix and the determinants. See, this property also we will be able to apply when we will be doing the like row operation, column operation, when we will be just uh, make any of the rows 0 or something. Then this type of property we will be applying over there. We will be discussing that concept also. So we have from here we can say, let me take one example. Suppose we are having a determinant like this. Let's say 2k, 4k, here maybe 5k, and here maybe 8k. We are having a determinant like this. Then if you want to take k common, then we can take out k common from the first row. Okay, the first row will become only 2, 4, 5k, 8k, like this. Or maybe from one of the column we can take out k column, k as a common factor, and then we can take out this k common from the second row. So k we have taken out common from the second row also, so it became 2, 4, 5, 8. So here we are having k square. Okay, similarly, if you understood this concept, then there is a theorem, there is a property which says that if A is a square matrix of order n, then if we are having this k into A, That means it will be k to the power n times a. What's the meaning of this? The way you can see, it was of order 2, right? 2 cross 2 we are having over here, it was of order 2. So we have got 2, k to the power 2 over there. Okay, so k we have taken out common from the first row, k we have taken out common from the second row, and eventually it became k square. When we were having the determinant in the form of, like, the order was 2 cross 2, when the order was 2 cross 2, it became k square. Similarly, we are saying when there will be when we will be having a matrix of order n, then for determinant k times a, like this, we will be having k to the power n outside. We can take out k common from the, instead of row, we can say the same thing about column also. We can say that we are taking k common from the first row, from the second row, from the third row, from the fourth row. Like this, we are taking out each and every rows k, and then we will end up getting k to the power n. Or we can say that we are taking out k column from the first column, k common from the first column, from the second column, from the third column, from the fourth column. This way we are taking out common all the k from n columns. Okay, and hence we will be having this property. Okay, for example, you can see, suppose we are having 3k, 4k, here 8k, here 7k, 6k, 3k, here 5k, 2k, here again 5k maybe. If we are having like that, then we can take out k common from the first column, k out. The first column became 375. At the same time only you can take out all of the k common, but for just for the concept I am doing it one by one, so that it will make sense to you. Like this, 8k, 3k, 5k, and then we will be taking out k from the second column, so it will be k into k, 375, 462, and the third column k is still there, and that also we will be taking out common. So we will be having k, 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 and then we'll be having 375, 462, 835, like that. Okay, here you can see we got k to the power 3, and it's the same thing. So when we are having, when there is a matrix A in the of order 3, okay, the matrix A of order 3, and that's determinant if we are taking out, then you can see we ended up getting k to the power 3 over here. Order 3 was there over here, and we got k to the power 3 over here. Okay, let's apply these properties which we have learned over here in few questions. Let me take few questions. So the question is, if A is a square matrix of order 3 and determinant of 3a, please don't get confused, this is not modulus of 3a, okay, this is determinants of 3a, is equals to k determinant of a, then write the value of k. Here we are having A as a square matrix of order 3. Okay, so matrix will is having order 3, that means 3 cross 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is how we are having the matrix. Okay, Now only we have discussed the property which says that when A is a square matrix of order n, then this is the property we are having. Let's write the property. We know the property says when, I'm just writing the property, okay, so that we can apply the property over here. When A is a square matrix of order n, then what we have written over there, we are having here that determinant in this form is equals to k to the power n. If k is there with each and every element, then we will be having k to the power n outside and only determinant of A. Okay, so here can I say that this one determinant of 3A will be 3 to the power what? Order of the matrix. Order is 3. So can I say 3 to the power 3 and then only A by applying this property? Can I say this? See, you don't have to write everything over here, or even if you are writing the property, that is completely fine, that we are using this property and according to this property we are getting this one. This is the property I have written, okay? It was nowhere it was given in the question. This is the property we are having, and according to the property I have just taken this one, this side, and according to the property I have expanded it. So can I say it will be 3 to the power 3 and then determinant of A? Yes or no? Because our matrix is of order 3 over here. When it was of order n, then we were writing k to the power n. I have shown you when we were having order 2, then we have got k square. When we were having order 3, then we have got k cube. So for order n, it will be k to the power n. But in our question here, our matrix is of order 3. So it will be k to the power 3. What is k? K is just a scalar. Here instead of k, like if we will focus over here, it is given as a determinant of 3a. That means 3 is there with each and every element, okay? And then it's having order 3, so it will come out as a 3 to the power 3. Is it clear to everyone?
Yes, ma'am.
Okay, k is 27. Okay, row operation is deleted for you. That's fine. That's great, because that is the main thing in higher level. When we again when if you will continue with the mathematics, and if you will just see this matrix chapter, there will be like row operation, column operation, and every concept will be there. So freshly you will start from there. This is the basic, the plot you are getting from here, and after this you will be able to get the concept over there. Okay, no worries. I am just going according to the like recent version of NCRT, and all the question paper also I have collected. So accordingly we are discussing the concept over here. If anything is excluded, I am not going to take over here. Okay, so yes, this is what we'll be getting over here. Now if we got 3 to the power 3, we know it will be 27 and determinant of A. Here what we have to find the value of k, and yes, you have written it correctly in the chat box that it will be 27. If we will compare it with k determinant of A, okay, this part, okay, then we can say k is nothing but 27. Okay, let's move ahead. Just a moment, no? Okay, so the next question from the same concept we are having over here, which says that if the determinant of a matrix A of order 3 cross 3 is of value 4, then write the value of determinant of 3A. Okay, again it's like the previous one only. Here this one you can see it's exactly like the previous one. Here also the order is 3. Okay, order is 3 cross 3. So if the determinant of a matrix of order 3 cross 3 is of value 4, what's the meaning of that? It says that if the determinant of this type of matrix is having a value 4, determinant is having the value 4. Determinant of A is having the value 4. Determinant of A is having the value 4, which is given as a first, like first information. According to the question, we are having as a determinant of A is equals to 4. Okay, that we have to understand by reading the question. Now it says that if the determinant of A is 4, then write the value of this one. We have to find the value of this one. Again, we can apply the same concept. If the order is 3 cross 3, if we are having 3A like this, then if we will just take out 3 from the determinant, then we have to take out 3 from each and every row, or maybe we can say that we have to take out 3 common from each and every column. Since there are 3 rows, so it will come out as a 3 to the power 3. Okay, and then determinant of 3. Just like the previous one, here we will be having 27, and here the determinant of A's value is also given, that is 4. Now we will be doing the multiplication to get the answer. So it will be 7 4 times 28, 8 carry 2, 4 2 times 8, 2 10. 108 will be the value of this one. Okay, read the question carefully, you will be able to get it. If the determinant of the matrix A of order this is of value 4, determinant is having the value 4, then write the value of this one. Okay, so basically this property says that if we are having maybe uh, uh, if we are having 3A like this, that means 3 is there with each and every element of this determinants. Okay, and we have to take out 3 as a common factor from each and every row, or we have to take out 3 as a common factor from each column. Now according to the number of column or according to the number of row, the power will come out when we will be taking out the common part. Now let me take another question. Now the next concept over here is we will be taking question which is based on the area of the triangle part. So there with the help of determinants also we will be able to find the area of the triangle. Okay, previously you must have learned few formulas for area of the triangle. The basic one was 1 by 2 into base into height. Then you have also learned the concept of Heron's formula, where we were using the side, each and every side's length, and we were finding the area. Okay, and area formula over there was, just a second. So we were finding the area over here, and that formula was s under root s minus a, s minus b, s minus c. That in lower classes maybe you have seen this formula, the Eron's formula and the basic formula, 1 by 2 into base into height. Here in the coordinate geometry chapter also you must have seen the area formula. Here also we will be able to find the area by using the concept of determinants. Okay, so if we are having a triangle like this, and here let's say A is a point whose coordinate is x1 y1, B is a point whose coordinate is x2 y2, C is a point whose coordinate is x3 y3. Then just a second, no? Now with the help of determinant we will be able to find the area of this triangle, which is area is equals to since we are talking about area, it has to be a positive value. Okay, we will not say that area is a negative number. So that's why at first we are taking a modulus, so that whatever we will be getting after doing the calculation of area, that will be a positive number. Modulus of 1 by 2, determinant we will be finding here x1 y1 1, x2 y2 1, x3 y3 1. Like that we will be finding the determinant, and this is the formula for finding the area by using the concept of determinants. This is the formula. Please be careful, area will never ever be negative. However, determinant can be 0, determinant can be negative, determinant can be positive. So if in case we will be getting negative, so we can make it positive because it's inside the modulus. Okay, this much square unit is the, we can say this is the formula for finding the area of the triangle. Now there is few more concept over here which is related to, okay, collinear, collinearity of 3 point. So when we are talking about collinearity of 3 point, collinearity, here if you will focus on this name collinear, co means together, linear means line, same line. Okay, so the 3 points must be sitting on the same straight line. That's the meaning of collinear. Okay, and when we are talking about collinearity, we can say this, like in this triangle this 3 point are not at all collinear, and it will never ever be collinear. Okay, so if we can take the same determinant and we can say that when that will be equals to 0, then we can say 3 points are collinear with each other. Okay, so the same determinant we can take and we can say if the value of this one, x1 y1 1, x2 y2 1, x3 y3 1, this x1 y1 x2 y2 are just 3 points. If this will be 0, then we can say these 3 points are collinear with each other. Okay, now the next concept, here we are having, anyone asking anything, let me check. Area is equals to 0. Area, when we are talking about area, no, we just we are thinking about that it's this occupied portion. So when the area is 0, that means there is nothing, like there is no shaded part, there is no occupied part, no part is there over there, like we don't have any part. Okay, so area 0, like negative we will never ever get, or even if we are getting, we will say area, we can make it positive by taking the modulus. And area, yeah, okay, if you are talking about the collinearity condition, yeah, that's true that we will be taking the same area formula and we are writing is equals to 0. Okay, then we can say all the 3 points are collinear with each other. Because when we are having the triangle, like all the 3 point are not lying on the same line, it it will not be the case, all the 3 point will not be lying on the like same straight line for triangle, and that is the determinant for triangle. So when we are having 3 point on the same straight line, that has to be 0. Okay, now there is one more property over here, one more formula over here. Equation of a straight line passing through 2 points. Equation of a straight line passing through 2 point. In class, in previous class, you must have seen this formula: y minus y1 is equals to y2 minus y1 by x2 minus x1. In bracket x minus x1, this is the equation of a line passing through 2 points. Here we will be taking, suppose we are having a straight line, here we are having x1 y1, here we are having, let's say, x2 y2, and here we are having x comma y. So again, all the 3 points are lying on the same straight line. That case we can take the case of collinearity, and we can write the determinant, that is x1 y1 1, xy 1, x2 y2 1, and that is equals to 0. When we will solve this one, we will get a equation in terms of x and y, and that will be our equation of a straight line. Okay, so equation which we used to find by applying this process, same equation